configuration security posture and configuration management than I ever had to do when I wasn't virtualizing, and it's part of the story, right? Let's skip through latent assets and provisioning and skip right on to the compelling issue here is that virtualization, with the flaws that we've pointed out, and they're not really flaws that anybody else doesn't have, all large software systems have significant number of flaws. We're just going to recognize them as they emerge and need to do something about them. So this is nothing new. But the new values are, I get huge improvements in efficiency. I get one piece of iron that I'm managing and procuring. It's generating a certain amount of heat, and it's taking up a certain amount of floor space, and I'm getting more work out of it. Hallelujah, I'm going to do more of virtualization for that reason alone. I also get better agility because I can easily provision and re-provision environments. New business need shows up, I can be more responsive to it. New business problem shows up, I can address it more rapidly. I'm going to do it for that reason. Virtualization can deliver, doesn't inherently and automatically do it, but can deliver the same amount of work for less power because I'm getting this better efficiency, a greener sort of mechanism. And given that many, many corporations are running into the wall in terms of being able to get more power, more floor space, more air conditioning, they have a reason to virtualize to be able to get the headroom they need to be able to grow. Finally, virtualization still reduces cost, and what that means is with those compelling drivers, we're going to do virtualization. Fait accompli, it's going to happen, and it's going to happen aggressively. What we have to do is wrap our heads around the idea that we're going to do the work it takes to manage security in those environments despite the additional complexity. And we're going to. More than that, there's lots of very specific guidance to help us get started. Baseline, this is where you should start about this from very authoritative sources. In fact, let me emphasize, lots. So let's look at a couple of them. From Gartner, we have one of their original documents about what are the dimensions along which security changes when you do virtualization. The point's here not to know any of this stuff, just to know that Gartner made a statement, and it was pretty comprehensive. In fact, it was 17 pages and 6,483 words. Enterprise Management Associates followed on with a lot of the stuff from Andy Mann, and we wound up with more information in that environment. In addition to the analysts, we had the consensus guidance work from the Center for Internet Security. Note here we have, I believe, the generic virtual machine hardening guidelines, the Xen guidelines, and of course their CIS guidelines for ESX. Those have since been updated for a new version of VMware, and we're going to see more stuff coming from them in terms of Xen as well. We'll even see some Hyper-V stuff as that stuff emerges. Note, very interestingly, we're getting a little bit further along in the process, and we get more participants, including the Defense Department. This is the Defense Department's guideline on virtualized storage configuration, just to give you some inkling about what some of those 32 high-level controls are in controlling storage area network configuration in those environments. We also get guidance from the Defense Department on configuring and managing a particular virtualization server, and look what just happened to the content size. 82 pages, 117 plus controls, and about 27,000 words worth of guidance, right? And this is to meet, of course, those requirements. We got information as well from the vendor as we've updated from them ESX 3.5 and ESXi, so we get additional guidance dealing with additional new features, new capabilities, new insights, and of course, new permutations of the platform, permutations that don't have a console operating system sitting on top of the virtualization environment. So we've seen the split between the hypervisor and the environment in which you get access to and manage the hypervisor. Interestingly, as the guidance from VMware came out, we began to see lots more diversity in what they were addressing. So we're seeing the guidance address not just how do I configure this hypervisor layer, but how do I configure all of the relationships between the hypervisor and Virtual Center and other hypervisors and all of the various consequences. So there's a realization that's emerging that the hypervisor operates in an environment where there's lots of interfaces, lots of interactions, lots of things to control, lots of things to pay attention to, lots of places to apply best practice configuration. Best practices, by the way, aren't adequate to getting to the point where you've done the job in terms of security. They simply articulate the things you can leverage, the things you can automate in order to free up the time so that you can do the rest of security, which goes everywhere from business risk and governance all the way down through organizational policy articulation and all of the security stuff that has to be done in order to complete the story. This simply takes some of the drudgery out by giving you a best practice place to point to so you don't have to reinvent the wheel every time anybody decides to embrace the technology. Big picture, well, we've got lots of guidance, as I suggested, from lots of sources about lots of things in virtualization. The good news is not where these guys are different. The good news is where they are coherent. We've seen a convergence and a consensus emerge as to what's the most important stuff to pay attention to in managing virtualization stacks, whether it's storage virtualization or alternate virtualization, server virtualization mechanisms. Similar guidance will emerge on application virtualization side of the fence, network virtualization, and all the other forms of virtualization between. Let's talk about coupling. Coupling is the idea that when I start sharing resources of any kind, the assets that share the resource wind up coupling to some extent the security posture and the behavior of the assets. The next 4 examples are attempt to make that concept very, very concrete. The first is, of course, that I've got 3 different servers, and they have 3 different sets of memory, 3 different address spaces, and 3 different working sets in terms of the application running on them. How many of you are familiar with the concept of working set? What happens when the working set of an application exceeds the amount of physical memory that's there? Paging and swapping, right? Because the working set is the amount of memory I need to keep this thing running. When the physical memory is less, then I'm starting to reference outside of those pages, so I start causing page faults, right? So I start slowing things down, sometimes by a lot. But the good news in this environment is that that happens here. What do I affect? This guy. Nothing else is affected. Now, co-host those guys and virtualize them. And all of a sudden what I'm concerned with is the sum of their working set sizes. And it's when that exceeds physical memory that I have to worry about page faulting occur. Now, if page faulting starts to occur, I start swapping out pages for these guys. What's the effect on these guys? Yeah. Now, suppose I take advantage of those features in a virtualization server environment that sandbox the memory. That says, okay, this guy's going to behave. He's never using more than 1 mega memory. He's not using more than 2 mega, and he's not using more than 3, and together I've got 6 mega memory on the system, right? Now suppose one of them starts using more working set size than the memory you've allocated to him. What's going to happen? Page faults. So the host bus adapter is going to start getting loaded down with his page faults, and what does that mean for the I/O availability of these guys? Note the bowl of jello syndrome. Where I push in the behavior and try to control it on one edge, it bulges out someplace else, right? Let's look at another example. This time, the host bus adapter, right? So we're looking at the other end of the system. We've got hosts, they have their host bus adapters, and those host bus adapters have cache. And they have cache, why? I'm reading sequential blocks of memory that are bigger than my ability to stash those into my variables in the program, right? What happens with the controller? So you're going to say, oh, you read that memory last time. You're likely to read these in the future. Am I going to cache the whole sector? If I'm smart, I am, right? So they all have their own cache. If this one does Gaussian distributed access, this one does normal, and this one does sequential, the host bus adapters will use the cache for whatever access pattern these guys are exhibiting. Now, co-host them. They have virtual host bus adapters, but there's one real cache here. This guy does lots of sequential accesses, loads up the cache. This guy does lots of random access. This does a different distribution of random access, and now this guy gets his turn again. What just happened to this guy's cache? How effective is it? So if cache is important to the behavior of an application, I've just coupled the performance of these applications by co-hosting them. They shared a physical asset, hence their behavior was coupled, right? Now, is there something you can do about this? Oh, absolutely. Monitor the cache hit rates on these guys at the I/O driver interface, and I know, should I have co-hosted those guys? But what it means is when I decide to provision something onto a virtual environment, one of the things I want to know is there a coherent, is there a sensical co-hosting that can go on there based on the sharing of the assets? Power and HVAC coupling. Very interesting. So lots of data centers decide I'm going to split my servers up into aisles, and I'm going to cool based on that because I can control hotspot formation and that stuff, right? So suppose I get my aisle pretty heavily loaded, a little bit lightly loaded, pretty heavily loaded, a little bit lightly loaded. I've got more stuff to do, and I've got a very available system out there. Is the right answer, spin up the next application over here? Anybody want to take a guess? So this guy essentially is not running anything. What heat is he generating? Minimal. Processors can sleep, drives can spin down, heads can unaccess. I can power